Are we live? Looks like we're live. Hello everyone and welcome to yet another Azwazin session. How about that? I bet you expect that shit to happen. Get ready. So let's make a little bit of an announcement and officially start the stream. So a red circle, right? So live on Twitch. And what are we doing on twitch.television? What exactly are we doing on twitch.television? Today we're hacking WebAssembly in C++. That's what we're doing today. So I'm gonna give the link to the Twitch channel where we're doing all that, twitch.tv/study. And I'm gonna ping everyone who's interested in being pinged, and there we go, we officially started this stream. So today we're gonna be doing a very interesting thing. Right, so some time ago I actually started developing like a game in Jai. Jai is a Jonathan Blow programming language. So I started to develop this game as sort of like an exercise, as a, you know, an excuse to learn this language. And recently we did a very cool thing. We ported that game to WebAssembly. And the cool thing about that fact is that Jai does not support WebAssembly in the first place, right? So we ported a language that doesn't support WebAssembly. So the thing it does support the LLVM intermediate representation, so it can spit out intermediate representation of the application it's compiling. So then you can do whatever you want with that intermediate representation, and we basically translated that to WebAssembly. And you can play this game without having the Jai compiler in here. So Jai break. So there you go. So this is how the game looks like, right? And you can play it without any recompilation or anything like that. So I'm gonna give the link in the chat, and I'm also gonna put that in the description for anyone who's watching on YouTube if I ever gonna upload this thing on YouTube. So let me open the description. So the description currently, this was some stuff that I probably not gonna upload. So let me maybe actually overwrite this entire stuff. So references, and in here I'm gonna give the deployed game, right? Deployed game. And also I'm going to give the source code of the game. So for anyone who's interested, you can find the source code in here. I'm going to copy paste that in the chat. And I'm going to also put that in the description. So source code of the game, right? There you go. So, but the problem is, we sort of hacked our way through WebAssembly compilation, right? So basically hacked. We have a lot of mosquitoes right now, unfortunately, and that also created an interesting bug that we effectively ignored just to get things done as quickly as possible, right? So we managed to compile Jai code to WebAssembly, but that code didn't really work correctly, and what we did, we simply ignored that. So, but today I want you to get back to that bug and actually fix it. And while I was researching how to fix that bug, I went to a pretty cool rabbit hole that I would like to share with all of you. So we're gonna go down that rabbit hole together, because it's rather interesting and not particularly intuitive, and also at the same time super cool. Right, and it's related to C++, I promise. We're not gonna do C++ right away, but it is related to C++. Okay, let's take a look at the bug. So I'm gonna start TeamUX and I'm gonna go to the source code of Jai, right? So the bug is the structure literals don't work, right? So the structure literals don't work. If we go to jailbreak and open the game, and let's pick the player, right? So we have a render player. Okay, so we don't have a separate function for that, but we have a big function render that renders everything. Let's try to find where we render the player. Not really the player, but the bar, right? So I think this is the place where we do that. Yeah, so if we are in a play state, we simply This doesn't look, this is a projectile. Here is the bar. Okay, so the bar color. We construct the bar color at runtime, right? So if I construct the bar color at compile time, this is not going to work. And I can do that using the structure literals, right? So let me actually put the structure literals in here. And if I try to recompile this entire thing, right? So by the way, off screen, I did a pretty cool thing. Essentially now the entire compilation of the game is done in Jai without any shell scripts. Right? I don't know if I actually said that on the stream, but essentially now there is a function build wasm platform that basically builds everything, right? And it calls to a function that like calls the external things in here, right? So you don't even need to have a shell script. So you can use Jai as the cross-platform shell, which is rather cool. So because this is one of the problems that I have with like C and C++, you can't just have like an easy cross-platform shell, right? So you can have a cross-platform build system, but build systems tend to get overcomplicated, and quite often I just want to have a simple build system, and it's usually a shell, and shell is not cross-platform, unfortunately, right? So in here you can use the language as the shell, and that is very, very convenient. So we have a lot of subscriptions, actually. Thank you so much everyone who subscribed. I really appreciate it. I don't get any money from that, but I really appreciate you throwing money at Amazon anyway. Thank you so much for Twitch Prime. Senior Whopper Pants, thank you. And Cherry Son Tofu, thank you so much for 4 months of the subscription. All right, so and let's actually try to recompile this entire thing. I'm gonna do opt jai bin jai linux, and I'm gonna do first jai. All right. So and another interesting thing now, what I did is. When I detect an assembly, right, when I detect an assembly, I remove the entire body of the function. And this is something that you can actually do in Jai, right? You can detect a certain construction during the compilation and do something with that. For example, remove it, right? So since we can't compile inline assembly blocks into WebAssembly, we have nothing to do with them, we can only remove them. So essentially you have to write a code that doesn't use such functions, right? So yeah, and the compiler also, I made the compiler to sort of warn you if the assembly code is detected, so don't use that specific function. It will be also kind of cool to maybe I don't know, throw some sort of a compilation error if you're trying to use that function from your code or something like that, but we'll see. So it's not particularly obvious how to do that. So we have some errors which are kind of weird. Oh yeah, I know what's up with that error. So this is like a fresh installation of Jai. So I'll probably have to go somewhere here. Yeah, so I'll have to add system in here. Okay, so let's recompile this entire thing one more time. Let's recompile this one more time, and maybe it will finally work. So it takes so much time, it's because it is like spitting out the intermediate representation. It's usually a pretty slow process for whatever reason. There we go. So also let me start the server so I can serve the WebAssembly. HTTP server 6969. I should have actually done that in an asynchronous way. All right, and there you go. So I already tested this entire thing. No, I didn't test this entire thing. Actually, yeah, there we go. So here's the problem. As you can see, there's no bar. There is no bar, and this is because, right, this is because I used the structure literals. If I construct structures at compile time, they don't work. If I construct them at runtime, they do work. And that's the bug that we have in here. Right, that's the bug that we have in here. So we'll have to wait a little bit, right? You know, the build of the entire thing is kind of slow because it involves like other things except Jai, right? External tools and stuff like that. Right, and if I refresh, as you can see, it works. So using structure literals simply does not work. And that is very, very interesting. Right, so one of the hints that were given to me about why this doesn't work were done by One Lives Left. I don't know if he's watching us right now, but yeah, he's another beta tester of this language. He said that the structure literals are located in a data section, right? So basically they are constructed at compile time and they're saved into the data section, and then they're referred to, you know, in the data section. So, but here's the thing. The way we hacked together WebAssembly is by simply converting, right? Simply converting the WebAssembly code to what is the textual representation of WebAssembly, and back to WASM several times, which effectively, apparently, removed the data section. So essentially, we're compiling Jai and removing the data section. Right, and that's why anything that involves the data section simply does not work in the final application that we compile. Does that make sense? Right, and the question is, why do we do that in the first place? Okay, if we don't do that, right, so here's what we're doing. So we're just compiling the file in here, right? So we're just compiling it. Let's see if it's going to compile or not. Also, let me actually not compile any native platforms, right? So we're only going to focus on WASM, right? So we're only focusing on WASM. So it should work, right? So we're just compiling the final thing, but the problem will start to appear when we'll try to link that object file, right? Okay, so as you can see, we're taking the intermediate representation and we are turning it into a file. So that went great, that went okay. And now what we can try to do, we can try to link that file into the final executable. So let's give it a try. So I don't see if I can just quickly uncomment something. I think I can uncomment something like this. All right, so let me copy paste it in here. Right, so I'm using a fixed O. Let's not use fixed O. I'm gonna just use the regular O. Right, so let's try to link that as well. So let's wait a little bit. And here's the problem. So it says, while trying to link this thing, it says invalid data symbol offset. Type table offset is this, but segment size is this. Right, so, and essentially we have a data symbol, right, a data symbol type table, which has the size of this thing, but the start of that thing is located beyond the size that is allocated for that segment. You see? This is rather strange, right? So essentially what that means, the compiler generated some data that is smaller than the pointer it tries to point to. Right, it generated some array of some size and then said, okay, so the symbol starts at that thing that is over that data. And I was thinking, like, why the fuck would compiler generate something like that? Why the hell would it even generate anything like that? And here is this thing. And then the very interesting thing occurred to me. So let's actually go to the standard library. Jai modules, I think maybe preload, or maybe compiler, I don't remember. I think it's better done by looking at the compiler. Right, so let's take a look at the build options of the compiler. Right. I remember there was something like machine, or maybe, oh, okay, so there we go. So there is an option called machine type, right? And the only thing you can put in here is x86-64, right? It supports only 64. And the comment clearly says, we only support 64-bit x86 at the moment, so this isn't very useful yet. And if we take a closer look at how we're trying to compile, so, oh boy. Essentially, the compiler is compiling everything using 64-bit pointers, right? It's a 64, it thinks that it's compiling for 64-bit machine. But then we're saying, okay, the target is WASM32. And here's an interesting thing about WASM32. WASM32 supports 64-bit arithmetics and stuff like that, but it doesn't support 64-bit memory addressing, right? So for that specifically, there is WASM64, right? So, but the problem with WASM64 is that it's experimental, right? So a lot of JavaScript runtimes simply do not support that. But we can try to compile our thing with WASM64 and see if it will work or not, right? So let's actually see if it will work. I'm gonna try to recompile this entire thing. I wish it was a little bit faster, but it is what it is. It's not about Jai, right? It's about external tools that we call to. So Jai itself is actually very fast, and as you can see, it compiled perfectly. So this is something that was discussed in the Jai Discord server for quite some time. People were thinking, how can I compile it to WebAssembly? Because every time I try to compile to WebAssembly, I get that pesky type table offset problem. This is how you solve that. You use 64-bit assembly to compile your Jai application. That's how we do that. But here's the problem. Okay, so if I try to now run this thing, right? And the cool thing about just using 64-bit is that you don't have to do any of those stupid hacks of like converting back and forth to remove the data section. You just don't have to do any of that, right? You just like compiled as usual, right? So, and if I try to reload this entire thing, so what's gonna happen? Oh yeah, so I'm using the old version, so let me actually go and remove the fixed. So this is the 64-bit version, and if I try to do that, it says invalid memory limits flag 04, enable via experimental WASM memory 64. So here's the interesting thing, this is the flag, there is no such flag for Chromium. So this is a message from the compiler. Right, so you need to enable that on the level of the compiler. Maybe there is a way to set that flag somewhere in the settings, but this thing is experimental. WASM64 is an experimental thing, and it's not that easily supported on all of the browsers, right? So you can probably enable that in Node.js, right? So just by providing that flag, but in the browser you can't expect the user to just have this enabled somehow, right? So we have essentially one option, right? So we just wait until this becomes like, you know, the stable feature of WebAssembly and all of the browsers support that. Or we can do something more interesting, right? We can try to do something more interesting. Is there a way to convert from WASM64 to WASM32? Maybe this is a good question. You're actually looking in a very right direction. Very right direction. So there is a degree of rightness, right? So essentially, let me see what we can do after all of that. So here we have main.wasm. Let's try to convert that main.wasm to what and see what we can do with that. So I'm literally going to do wasm to what, main wasm, right, main wasm, and I'm converting that to what. And as you can see, even wasm to what does not allow you to do that, right? So it doesn't like allow memory 64 by default. If I remember correctly, what you have to do, you have to use some flag to enable that. Oh, there we go. So you have to do enable memory 64. Right. Let me see. So we have to do enable memory 64, right? And let's see. So the essence of memory 64 is essentially the memory declaration, right? So in WASM32, memory declaration doesn't have this type in here, right? It simply doesn't have this type. It just like doesn't have anything in here. But memory 64 does have that. And what it means that every time you try to do any memory operation like a store or load, it accepts 64-bit pointer instead of 32. Okay, so can we just say, just use this thing then, right? So just use the 32-bit memory, and let's try to convert it back to WASM, right? To WASM. We don't have to enable anything, and I'm gonna just literally try to compile that. And we're getting very interesting things. We're getting validation errors, right? So this is not a valid WASM anymore, because for instance, you have a store instruction, right? So store instruction, and it accepts now, since the memory is indexed with 32-bit integers, it accepts 32-bit integer for the pointer and some value i64. In this case, it just saves i64. But instead, it got i64. So just because we said, okay, use 32 bits to index the memory, it doesn't mean that the code does not assume that everything is 64 bits, right? The code, the entire code itself, still expects the pointers to be 64 bits, right? So no matter how you change the definitions and stuff like that, the entire code is still hardwired to work with 64-bit integers. And this is like a interesting problem that we have to solve. My idea is the following. So only load and store operations create the problem. Only load and store. I have the following idea. What if we patch the WebAssembly code? Essentially write some sort of a program that searches for all of the store and load instructions, right? And then right before store and load, we're gonna insert another instruction that simply truncates the pointer to 32 bits. Right, essentially we allow the code to think that it works with 64-bit integers, but right when you're about to read or write into the memory, we convert them to 32-bit integers. Right, and I know for sure that the program is not going to use more than 4 GB of memory, so I know that it's not going to create the problem. Right, so we're sort of like emulating 64 bits, you know what I mean? So that's basically the idea. I want to write a program that takes 64 WASM64 and turns it into WASM32, allowing the logic of the program to think that it's still in 64 bits. Right, it's emulating these 64 bits, right? So it should be relatively easy because you just need to find all of the like load and store instructions and just like convert pointers right before them, and that will trick the entire thing into working. And if we manage to pull that off, that will be actually kind of cool. All right. Or maybe we can change the entire instruction itself, which is also pretty cool. So let's actually start working on this entire thing. Let's see if this entire idea is going to work in the first place, right? So let's actually see what we can do about that. let me maybe go to prop, and I'm gonna create, how I'm gonna say that? So essentially I'm gonna write a simple C program, right? I'm gonna compile it to WASM64, right? I'm gonna compile to WASM64, and then I'm gonna try to manually change those things to, like, you know, to 32-bit reads and writes, and see if it actually solves the problem, if it actually ports 64 bits to 32 bits, right? Because doing that with the jailbreak executable is kind of like kind of tedious, because it has like, as far as I know, it's like it has like 4,000 like read and write instructions, so it's like, you know, too much. Okay, let me see. Test 64 to 32 idea. Let's actually put it this way: WASM 64 to 32. Right. Test WASM 64 to 32. And let me see. Okay. So let's create a simple program, right? So let's actually create a simple program that we're going to compile to WebAssembly. So what we're going to do, we need some memory, right? We need some memory that we're going to address. So this is going to be, let's have a bunch of messages, right? So we're going to have const char, and we're going to put some messages in here, right? So here's the messages. Hello world, and then this is going to be full bar, and then maybe test, whatever, right? So we just need to have some messages. And we need some function that will maybe do something with these messages, maybe iterate them or something like that. Iterate messages, right. So I also need to know how many messages I have in here, and I want to be able to easily add those messages, so I'm gonna just have a constant, right, so define messages count. Alright, so we're gonna take the size of this array, so messages, and I'm gonna divide it by the size of a single element of that array, and this is how we're gonna compute the amount of messages that we have in here. Ertine, thank you so much for 1 month of, or for 4 months actually, of tier 1 subscription, the Twitch Prime subscription. Thank you. So let's actually iterate through this entire thing. I'm going to iterate in here, messages count plus I. And what we want to do, we want to print those messages somehow, right? So let's actually do print message, right? Messages I. So, and since we compile to WebAssembly, this function is probably going to be implemented in WebAssembly, right? So let's actually put it this way. Const char message. All right. So this is going to be an external function. So it's going to be as simple as that. So let me see if I can easily compile this entire thing. So it's going to be build sh. And bin sh set xe, and let's compile that to wasm32. So this is going to be clang target wasm32. Output is going to be main.wasm, main.c. Do we need anything else in here? I'm not really sure. Maybe that is actually it. So I'm gonna do it like that, and I'm gonna just actually do that. Oh yeah, we have to disable the standard library, so I'm going to take the flags from my existing project already, right? So jailbreak, so no standard library, something. So in here, we basically do a separate compilation, right? So we first compile this thing, and only then we're linking it. Okay, we can do the same thing. Wasm ld m wasm32. We're not going to have any entry point. Everything is going to be exported, right? And if something is not provided, we're going to just allow that. It's going to be provided like from the outside. And so the output is going to be main.wasm. Because of that, maybe this thing is not particularly needed, but maybe I'm just going to call it O. right? So it's kind of weird that Clang allows the object files with WASM still called O, which, I mean, probably makes sense, I don't know. And so what do we do in here? We just do it like that. So let me try to run this entire thing. And yeah, there we go. So I have a WASM file. Maybe on top of that, I'm gonna instantly also convert that to what, just for the debug purposes, right? So this is in the WASM main.what, right? So and if I try to run this entire thing, as you can see, it seems to be working, and this is the assembly. It didn't really generate that much assembly, right? So it's pretty straightforward. So I want to set up some you know, website that basically loads it into the browser, so we can test all of that. I'm going to copy paste that stuff from the jailbreak, right? So this is the jailbreak index. Where is my index HTML? So I'm gonna take that, and also gonna take that, and I'm gonna copy paste all of that in here. So let me see. We don't really need a canvas, right? So we're only gonna print to the standard output. And what we're gonna do in here, I don't really remember if I actually showed that on the stream, but I created a pretty cool function called make environment, right? So the thing about this WASM module is that it expects you to implement a lot of external functions, right? And the amount and the specific set of such function always changes depending on, like, maybe the compiler version and stuff like that. So I created a function that creates a proxy that basically allows the module to use whatever function with whatever name it wants. And if it's trying to use the function that is not available, when it tries to call to that function, it will just print an error not implemented given the argument, so we can instantly see what function you can implement, right? So that way you can say, okay, the environment is going to be make environment, and here are my functions. Right, if it tries to call to any of the functions, it will actually call them. But if it tries to call to non-existing function, it will actually log that it's trying to use non-existing function, so you can implement it later in here. Right, so you don't have to know what function the WebAssembly module wants upfront. Right, you don't have to know that. You can just implement them as the WebAssembly tries to call them. It's more dynamic. And that way, if the compiler changes something in its internal implementation and it requires different set of functions, this code still works to some extent. Okay, so in that case, I'm not gonna just like put anything in here right for now. And let me see. So we are fetching main.wasm. Rafaelo 38, thank you so much for Twitch Prime subscription. Thank you, really appreciate that. Okay, so in here we are searching for a particular function, right? So the function we're searching for, I suppose, iterate messages. Okay, iterate messages. Where is the load.js? I wonder if, like, so this thing, iterate messages, oh yeah, it doesn't require the dollar, right? So here it requires the dollar, but I suppose it's something very much WebAssembly specific, so I don't really care. So let me remove some of that stuff. Iterate messages, and we're searching for iterate messages, right? And let me simply call this function, right? Iterate messages. Okay, so I think let me start the server. It's Python 3 HTTP server 6969, and there we go. So if I try to refresh this entire thing, cannot read the property get context of null. Okay, so I still have a lot of code in here that is really not needed. Yeah, there we go. Okay, cool. So as you can see, it tried to print a message and it was not implemented, right? So, and it gave us 3 different pointers, right? Which is rather interesting. So they're actually decreasing, which is rather interesting, right? So they're actually decreasing. So what we need to do, we need to implement print message. So let's quickly do that. Print message. So this is a print message. And here we accept message pointer, right? So this is a message pointer, and we have to do something with that. Let's do message pointer. Right. message ptr. And let me see. Yeah, there we go. So message pointer. So the thing we need to do, we need to actually grab the message out of the memory, right? So what I want to do, I need to have an access to the WebAssembly module. So that means I need to have it somewhere here. So let's mark it as null. And as soon as we load the WebAssembly module, right? So let's actually replace this with W. I think I'm going to call W0 or something. I'm going to reassign it to a global variable, right? So as soon as we load this, it's part of the global variable, and all the parts of the code can use that quite easily. So what we want to do in here, we want to take a look at instance, exports, and I think memory is located within the exports, right? So memory is in here, right? So here is the memory, and within the memory we have the buffer, right? So we have the buffer, and as you can see, here is the buffer. Maybe I'm going to save that buffer somewhere in here, right? So this is the buffer. And what I'm going to do, I think I'm going to create uint8 array. So it essentially creates a view on that specific buffer, right? And if I remember correctly, you can specify sort of like a slice of borders for the buffer. So I can say, okay, start the buffer from that specific pointer. So this is where the messages start, right? So you can also provide the second argument in here, which is either the size or the last pointer. I don't remember. I think I need to look it up, right? So let's actually Google that. So let me see. So what's the other argument of U8 array? It's length. Okay, so this is actually convenient, right? So you can provide the length, but the problem is it's a C string. In a C string, we don't know the length. We have to calculate it, right? So essentially, the C string is like ends with 0, and that's how we know the end of it. And this is something that we'll have to calculate. So let me actually put the stuff in here, and let me run this entire stuff and see if we actually get some stuff. Okay, as you can see, we can clearly see some messages in the memory. We just cannot pinpoint their exact length, right? So because we need to calculate it. So let's actually create a function that computes the length of this thing. So maybe it's gonna straight up accept the uint8 array, because why not? It's gonna be function cstrlen, and we're gonna take the message, right? So the length initially is gonna be 0, and while message length is not equal to 0, we're simply going to increment that thing, right? And then we're going to return the length. So, which is rather cool, right? Because it allows us to do the following thing. We can do something like message length, where I just construct that and I take the length of that thing. So then later I can construct another view with the length. Okay, that's a pretty cool way of doing that, right? So, and we can take a look at the message itself, right? So here I can even save it like that. So this is the actual message. Okay, probably do it like this. Is it going to work? Yeah, so here are the 3 messages, right? So this is actually 3 messages. So the only thing we need to do, we need to convert it to the text, right? So as far as I know, there is a text decoder. It would be better to actually save it somewhere here. Text decoder. Text decoder. Right, and let's go back. Text decoder. I think it's just decode, right? So you just do message decode, and that should be fine, right? So I'm gonna put it like this, and if I do that, there we go. How about that? How about that? But you didn't expect that shit to happen. So, and this is literally the messages that we are trying to print from C, right? So essentially we got 3 pointers and we just extracted that stuff from the pointers. So we have a working example. WebAssembly was on 32 examples specifically, right? So, and one of the things I probably want to do, I want to compile the same example to WASM64. Right, so that's another thing I want to do, WASM64. So in here, I want to kind of preserve this like 32 bits because I think it's kind of useful. Let's actually do the following thing. I'm going to compile it to main32, right? So this is a main32, and this is a main32, and this is a main32, right? And essentially, I'm going to copy paste this entire stuff and just replace 32 with 64. Boom. Okay, that's cool. So in here, I'm gonna mark all of these things, and I probably I'm gonna remove them, right? So we'll remove them, and I'm running build sh one more time. And okay, so maybe for that thing, I'll have to implement enable memory 64, right? And there we go. So we have two sort of variants, like a 32-bit variant and 64-bit variant, right? And here we can actually switch between them, I suppose, right? So this is 32, it works. 64 doesn't work, so in browser specifically it doesn't work. Okay, so what I want to do, I want to just take this thing and try to patch this thing manually and see if that entire idea that we have even works, right? So I'm gonna copy paste that to main 64 to... Usually, you know, usually people do like what to wasm, they say to, like a number, right? But in this case, it's just like, it's already a number. So 64 to 32. You know, why not? I think it's a pretty cool name, right? 64 to 32, right? So maybe this is going to be the name of the conversion tool, right? So this is going to be, so the tool that converts 64-bit WASM to 32 one is going to be called WASM 64 to 32. And it's, what's fun is that it's 5 numbers, but they're really easy to remember, right? You convert in 64 to 32, right? So that's the name of the tool. Main 64 to 32, yeah. So let's call it like this. I think I like that. I think it's pretty cool. So let me now go and replace this thing in here. Since this thing is so small, it's like 123 lines of code, it is super easy to just hack it manually, right? So let's give it a try. I'm gonna do wasm to what? Actually, what to wasm, right? So what to wasm, main 64 to 32, and let's see what we have. Right, so this is essentially what we do, right? So it accepts I32, but we got 64. So here, as you can see, this parameter is probably 64, but I don't remember how to convert the 64-bit to 32. I don't remember how to do that. Wasm convert integer instruction. Okay. Conversion, so not equals arithmetic conversion. Okay. Oh, okay. So convert I64 to 32. This is precisely what we want. How do I do that? Show me an example. I32 wrap I64. Okay. Let me see. So let me go back in here. So if I put I32 wrap I64, is it going to work? I think it worked. So this is load. In case of a load, we just have to do it like that. I32 wrap I64. Maybe I'm gonna actually put it in the clipboard. Right, and just do it like that. So this is yet another load. Yet another load. This is yet another load. So loads are actually easy. So I'm just thinking how we're going to be implementing that. So what we need to do, we just need to find the loads, and right before the loads, put this single instruction. So with the stores, it is a little bit more complicated, right? With the stores, it's a bit more complicated because, so let me actually comment it out. Let's support the comments like in the, oh yeah. So how do you comment? Let me remove that. Okay, so with the stores it's a little bit complicated because the pointer that we have to convert is the first argument. So there is an argument in front of it. So that means we need to be able to swap the elements somehow, then convert them, right? So then convert them and then swap this thing back. But as far as I know, the WebAssembly does not support the swap operation. So what we'll have to do, we'll have to find where the first argument actually starts. And it could be like a complicated expression. And as far as I know, both of these two values may be returned by a single expression in case of the multi-valued return, right? Because the functions in WebAssembly can return several values, and I think it's an extension, but I don't think it's a unstable extension. I think it's a pretty stable extension by that point. So like finding where to put that conversion thing for the store is actually not that trivial, right? So we'll have to think how to do that, right? So it is not particularly trivial. Okay, the same store in here, right? So it's just i32 wrap i64, and we have data. So if I remember correctly, data accepts a pointer within the memory where to place that chunk of data, right? So essentially you allocate data in here, and then you say, okay, but starting from here, just hardcode this data into the memory, just place it there. And since it refers to the memory, it also refers by either 32-bit pointer or 64. Since it's a WASM 64, it puts 64 in here. So I suppose what we need to do here is just replace this with that, right? And it compiled, right? And now we have a thing, right? WASM. What's interesting is that it's a bit. Is it bigger than 32? It's actually smaller. This is weird. So it is smaller than actual WASM 32, right? So if you want to save on memory, compile this thing to 64-bit and then convert it to 32. I wonder why the fuck is it like that? But anyway, so let's actually do this thing. 64 to 32, and let me see if it works. Ooh, this is actually very cool. Can I convert a big int? Okay, so 34. Here is an interesting thing. I think this is a reason why memory 64, right, WASM 64 is an experimental feature, right? 64-bit integers are not representable by JavaScript numbers. They're not, right? Because as far as I know, JavaScript numbers are floating points, right? So they're actually using NAND boxing to, you know, to implement like different types of object to distinguish between them dynamically, which means that they have 48 bits for an integer to represent. So anything bigger than that is considered an unsafe number, right? And to circumvent that, they came up with a thing called big int, which is actually long arithmetics. So, and that creates a friction on a border between JavaScript and WebAssembly, because WebAssembly supports 64 bits easily, but JavaScript doesn't. So every time WebAssembly returns 64-bit integer, it is actually interpreted as big int, including pointers. So now, whatever pointers we receive in here, they're big int pointers. So I suppose the reason why this extension is still unstable is because of that friction between JavaScript and WebAssembly on the border of 64-bit integers. We're living in 2022, by the way. This is a year 2022. We can't migrate to 64 bits still, because of some stupid toy scripting language. Thank you very much. Anyway, so we know that it's not bigger than 48 bits, right? We know that it's not. So the thing we can do, we can straight up just convert this big into a number, right? So we can just treat it as a number. There we go. Written in Greek by one person. In all fairness, like modern JavaScript is actually, you know, it's more than 1 week of work, right? All right. So let me see. Okay, and it works. This is actually sus. Right, we got an executable that is smaller than the native 32-bit executable, and it works somehow. So, but the answer is yes. So this approach actually works. So essentially, to take 64-bit program, WASM program, and convert it to 32, you have to change the memory. I suppose also change the data if you have any data, go through all of the reads and writes or loads and stores, and convert the pointer that they accept to 32 bits, like basically like wrap it around, right? But here's the problem, like store instructions actually bother me, right? So the store instructions actually bother me because as you can see, okay, we can probably create a function that accepts i64 and i32, right? And that way we can basically access the previous argument regardless of how it was calculated. Again, so this argument can be calculated like in many ways, right? It could be an expression, so I cannot just take the previous instruction because the argument might be computed somewhere here, but through the stack operations it just like remains here. Right, so this is a huge problem, right? If it was in front of the store, that would have been way easier because I could have just like insert the convert instruction and that is it. But now I have to find the previous argument, and the distance between the store instruction and the previous argument can be huge, right? It could be like 10 instruction, can be 20 instruction, I don't fucking know, right? It depends on how the compiler decides to generate this shit. So what I'm thinking is that we can do a function call, right? Just call to, I don't know, store convert, store wrap, right? And this function accepts i64 and i32, and then within that function we already just like take the previous argument quite easily because everything is collapsed, so to speak, and then return everything. But the problem is here, we have to generate such function for each type of a value. Right, if the store accepts 64-bit value, if it wants to store 64-bit value into the memory, we'll have to have a separate function for that. So we have to do store, I don't know, i32, store i64, store i8, and whatnot. Maybe f32, f64. We have to generate like this kind of function for each of this value. And I don't think it's a problem, right? Because we're going to be doing that automatically, right? We're going to do that automatically. We can just write the code that injects all of that generates all of the functions and injects them into the WASM so we can call them, right? I don't think it's that big of a problem, you know what I mean? So let's actually give it a try. Let's see if we can create such function. So let's create func. Oh yeah, I remember that. So you actually have to, in WASM binary format, you have to first declare the type of the function, and only then you can use that type in the function. Even though the text format allows you to provide the signature in here, I think in the binary format it still expects it to be here, but I don't quite remember for sure. So I might be wrong with that. Don't quote me with that. Right, so let's actually create a type. Right, so this is going to be type number 2, and this is going to be a function that accepts two parameters, 64-bit pointer and 32-bit value. Right, and I suppose it returns both 32. Right, so let's create a function which is store wrap 32, maybe i32, right? So, and the type of this thing is going to be term. So in here, I don't remember. So let's actually try to compile this and test it and see how it's going to compile. So expected i32, if I remember correctly, the parameters are considered the local value. So I can do something like local get 0. Right, I don't even have to do it like that if I remember correctly. Yeah, it does work. So, and local get 1. There we go. And I can put i32 wrap i64 in here. There we go. So, yeah, essentially we just need to yeah, we just need to create such function for each individual value type that we want to store, right? And every time we store something, all right, we can just call to this function in here, and it works, and in here it works as well. So we can do something like that, right? So, but again, we'll have to generate that for all of the types, right? We'll have to generate that for i64, for you know, F32, and so on and so forth, right? But since we're going to be doing that programmatically, it's not a problem, right? So it is not a problem whatsoever. Okay, so this is basically the plan. So this is mechanically what we need to do, right? So this is a very small executable, but we need to do that on a bigger scale, on a way bigger scale. So the question is how we're going to be doing all of that, right? How we're going to be doing all of that? Well, we could write WASM parser ourselves. We can do that on the level of the text, but doing that on the level of the text is not really robust. I would like to actually parse WebAssembly, like properly analyze it and modify it, patch it, and then save it back, right? So we can try to do that from scratch, which is kind of tedious, but we can take an already existing code that can parse and generate WASM, right? And in fact, we've been using such code since the start of the stream. We have two utilities, WASM to WAT and WAT to WASM. First one is capable of parsing binary WASM, and the second one is capable of generating binary WASM. So why can't we take the source code of these two things and just hack it and implement utility, a new utility that does whatever we try to do in here? You know what I mean? So both of these utilities, they come from a toolset called Wobbit, right? So it's the WebAssembly Binary toolkit, and it's written in C++. So my idea is to basically take these two tools and create a new one, a combined one that reads the WebAssembly binary, patches it, and saves it back, basically converting 64-bit WASM to 32. So yeah, we can finally start the main topic of today's stream. Like, I spent 1 hour explaining the justification of what I'm about to do. Right. Alright, so yeah, let's actually download the source code of this entire thing and let's try to hack it. So I'm gonna do that. Like I literally just did 1 hour intro. This is 1 hour intro. Okay, let me go somewhere here. Do I already have a Wobbit? Okay, so I don't have a Wobbit. I'm pretty sure I'll have to do a recursive shit. Like every time I'm cloning one of those goddamn projects, I have to do recursive shit. Do I have to do recursive? Yeah, I have to do recursive because all of them use submodules. Recursive. Okay. Yeah. All right. So I hope it's not going to take too much. Google tests, test suites, WASM C API, WASI. Alright, so it uses CMake, so let's actually try to build it. Usually with CMake, you have to do build, right, and then CMake ... Yeah. So, let's see if we can build that. Okay. And go. Apply names.cc, binaries.cc. Binary reader, maybe this is something that we'll need. Binary reader IR, intermediate representation. Very interesting. So we're getting very interesting things. So maybe while it is compiling, I don't know for how long it's gonna go, but I really want to make a small break and maybe make a cup of tea. And after the break, we're gonna try to hack this thing and see how it goes. All right. So we finally built it. So let's give it a try. Let's see what we can do. Do we have any of these? Okay, so here are the executables, right? So wasm, what to wasm, and wasm to what. Here they are. And I wonder, like, where do they even start, right? So maybe they have like you know, the entry point somewhere. Maybe the file that contains the entry point is literally called wasm to what. So I think this is how we do that. Wasm to what. Apparently it is not. So, but maybe I'm actually don't know. Okay, find type file name wasm, maybe, yeah, wasm to what. And let's do something like this just in case it has any prefixes. Oh, okay. Oh, there is even like a folder for tools. Is that the things we have? Okay, so this is the folders where there are entry points for all of the tools in here, right? So wasm to what, wasm obj dump, what to wasm, and stuff like that. And I suppose they just share this code, right? So there's what writer, which is kind of useful, right? So is there here's the binary reader, so we can do this kind of stuff. So that's pretty cool. Okay, so I'm curious about, like, the first thing I want to do, I want to be able to read the binary format, right? So that's the first thing. So because of that, I'm interested in how wasm to what works, right? So here it is. Let me find the entry point. Okay, so entry point, there's some stuff in here. Web try. I wonder what the fuck is this. Define. Okay, so it's for exceptions, with exceptions. So there is a parameter that allows you to enable exceptions, and in that case there is a global try catch that catches everything. Well, not everything, but it catches the bad alloc. What a useful macro. Okay, we're off to a good start. So I already like that. Okay, so we're initializing stdio. I have no idea what the fuck this is. Okay, and it's only for MSVC, and on MSVC it just like does something with stdio. So much useful code so far. I really like that. Okay. So, okay, here we read the file, right? Read the provided file. So parse options. Parse options is actually rather interesting. So they have their own option parser, which we're probably going to use. So, and it's based on lambdas. Would you look at that? So you provide the name of the parameter, the description, and the lambda that is going to be triggered when you encounter such things, so you can set up your global variables and whatnot. So that's pretty cool. All right. So, an amazing Georgia, thank you so much for Twitch Prime. Thank you. Rafael 3238, thank you so much. Ertinay, the Urator. If I didn't mention anyone, like someone, and yeah, someone, please forgive me. So, okay, so here we have some parameters, and yeah, this is actually pretty straightforward. I really like that. So now we read the file. And if we succeed, we set up read binary options. Like there's quite a few options in here. And then we read binary IR. Right, we read binary IR. Where do we read that? I'm not really sure. I guess we're reading that into modules. So, and what is a module? Class module. Is that a class? Oh yeah, okay. So the problem with C++, by the way, is that you have a type and you don't even know what it is. Is that a class? Is that a structure, which is literally pretty much the same thing except, you know, visibility stuff? Or is that an enumeration? I don't really know. So the decision of actually making the definitions of the type in JI start like literally the same, the name and then colon colon, is actually quite genius, because you can find that type regardless of what it is, whether it's a structure, enumeration, or anything. They all start with the name colon colon. Right, so, and then only the structure enum or something else, right? So this is actually quite convenient. In case of like C and C++, it's not particularly convenient, right? Because different kinds of types are declared slightly differently. So, and I suppose it's a module, so class module, and I'm not sure if that's the module. Is that a struct module? So, okay, there is a struct module, and it's conveniently located in intermediate representation file. I suppose... I really like that. So this is a structure, so I have an access to all of this shit, right? So I have an... So there is a function read binary IR, which just gives you a bunch of vectors, which are tags, functions, globals, imports, memory, right? So we just have to call that, we just have to look into the memories and just set something there. And I'm pretty sure memory contains like the type that it can be indexed by, you know what I mean? So class memory, okay, so that means it's a structure memory, there we go. And it has a name, memory can have a name, and it has something called limits, page limits. So maybe the type is located in those limits, right? Class limits or struct limits, and it's defined in a different file. It's the princess is another castle, right? So class limits, structure limits. There you go. It's located in common.h. So there's a bunch of constructors here, and is 64, right? So you just like put a boolean in here. So it's not even a type. It's literally a boolean that controls whether the memory is 64 bits or 32 bits. Okay, not bad. So it's pretty cool. I really like this C++. This is like a C++ 03. Good old C++ 03. Is that like an enumeration class? I think it is an enumeration class. Anyway, so yeah, we just need to read this entire thing and then like patch it, and we're good to go, I think. So what we're gonna do, I really want to create like a separate new tool, right? So like create another file in here. So let's actually create something like wasm64to32 cc. And I don't even know what I'm doing here, so it's an IO stream. Main, we definitely need... So the problem here is that CC does not set up my simple C mode, so maybe I'll have to do something about that, but maybe later. So character, something like this, and let's do the following thing: std cout hello world, std handle, and I suppose we'll have to modify cmakelist.txt. So wasm, let's actually find add executable, right? So I remember cmake a little bit, right? So I did a lot of C++ commercially, and I of course used cmake. So I do remember that to declare an executable you have to use add executable directive. I do remember that. Okay, so I suppose there are some functions that, okay, it's a wabbit executable, so they tuck the boilerplate of defining executable under the function wabbit executable. So let's take a look at this function, and okay, so there you go. So here are all of the build tools in here. So that means I can literally just copy paste this code, right, and just call this wasm 64 to 32. There we go. 64 to 32, and let's see if I can rebuild this entire thing. Alright. You know what's cool about CMake? Is that the empty build that doesn't do anything takes 1.5 of a second on my machine. This build literally doesn't do anything. The only thing it does, it checks whether it's already built the thing that it needs to build, and then it moves on to another thing. So, and that takes 1.3 seconds. Very cool build system. I'm really happy. Okay, so do I have WASM 64? There you go. So I have a WASM 64 to 32. Isn't that cool? Isn't that cool? I think it's pretty fucking cool. Alright, still faster than Rust. Yeah, I agree with you. Okay, so I have 2 new lines in here, by the way. So this is the first new line, and this is the second new line. When you don't have enough new lines. By the way, hello. Okay, so I usually, when I'm going to someone else's code base, I'm trying to mimic whatever they're doing, right? So I suppose I have to do that. I'm not really happy about this thing, but since this is not my code base, right? So this is how I'm supposed to do that. And I'm supposed to have the program main, right? It needs to be separated, and there should be a global, you know, switch case or something like that. Sure, I'm totally fine with that. And I suppose we need to initialize the stdio just in case somebody will try to compile that with MS3C. And we also need to parse the options, right? We need to parse the options. I'm not really sure what kind of options I care about. But yeah, maybe I'm gonna accept the file path, the input file path, because why not? Right. So, and I'm gonna do option parser. So in here we do WASM 64 to 32, and here we have a description. Right, and description is this static thingy. Right, so this static thingy, and this is a lot. Right. So read a file in the WebAssembly binary format. Okay. Convert WASM 64 to WASM 32 by tricking loads and stores into by let's not say tricking, by converting all pointers for loads and stores, all pointers accordingly for loads and stores. This doesn't explain anything, actually. This is the worst description I've ever written, but I cannot come up with a better description. I'm really sorry. So WASM 64 to 32. Okay, let's actually say test 32. Oh, actually 64. 32 WASM. So that means we'll have to support at least such flag, which is okay, which is fine. You know, like, again, you don't even have to know how to program. As you can see, you can just copy-paste the code, right? Just copy-paste the code and that's gonna be fine. So we have a verbose flag. I'm not really sure if I care about that right now. So the output flag seems to be rather convenient. So maybe this is something that I'm gonna add in here. Right, so I don't even understand what the fuck I'm doing. And my formatting tool is broken. Is that because of this? Is that because of this fancy string thingy? Right, so this is a raw string from C++ 69420. I don't remember what kind of features the latest C++ introduced, but I think that's actually the reason. Okay, it is. Okay, this thing breaks my formatter. How do you pronounce that? I don't speak English, I'm sorry. I'm really sorry for my pronunciation, because I don't speak this language like at all. I had to learn this language. Anyway. So, like, who needs these fancy raw strings? Raw gotcha strings. You know what I'm talking about? When you have just like a good old like multi-line strings, you can do shit like that. And it works. It worked 20 years ago, it works today. Why kids these days always need to invent new useless features when the old ones still work? You know what I mean? Like, I mean, we can do shit like that. Anyway, so, and it works. Let's go back. Wasn't to what? So, what else do we need in here? That's a good question. So, fold experts, I don't know what the hell is that. File name. Oh, okay, so, look, they have separation for options and for the arguments. And this is something that we need here as well. Right, so we also need the input file argument, and then we have to say parse this shit. Okay, so let's see if this entire stuff compiles. Right, so it probably doesn't, as usual. Welcome to C++. Okay, option part. Oh, we have to import some stuff, of course. Wasm to what? So what do we have to import here? I'm gonna import everything. Right. I don't really know what is needed in here, so I'm gonna just like literally import everything. Who cares? Okay. Welcome to C++. Cool. Option passer. Is that because... wait a second. Why? Ah! Sure. Of course. It almost worked. Okay, so there's no such thing as out file. So s out. Oh, okay, so they're basically like a couple of global variables that we can simply copy paste in there. You see, programming is easy. You just copy paste shit. See, it's super easy. Yeah. People like study programming for like 3 or 6 years. I don't know, in universities and stuff like that. It's easy. You just take the text and you copy paste the text. So there is no return statement in here, so we'll probably have to return the statement. And yesu, kawaii freaking desu. Okay. So we can actually do something in here. So input, right, and we can provide the input as in file, and if I remember correctly, right, we're also gonna have the output, out file. There we go. So let me see. So if I try to run wasm64-32, expected file name argument, right? So we provide this thing, input, but output is not provided. How do you provide the default value for this thing, right? So the output was never specified unless I do something like this, right? So, but if I have a default stuff, how do I set the default stuff? S out file. Oh, okay, wait a second. So it's done at runtime, right? It is done at runtime, I think. Or not at runtime? Or maybe at runtime. Yeah. So you convert the backslash to slash or something. No, it's not that. But how do you do that? Oh, okay, so I brain farted a little bit. So if it's not empty, right, so we're... Oh, I see. So we just... Okay, so it outputs to file, right, it outputs to file, but if no output file is provided, it just prints it to standard output. So this is basically how it's done. Okay, sure. Okay, that's fine. Cool. So we copy pasted a bunch of things. So let's actually start reading the thing. Let's actually start reading. What do we need to do in here? We need to allocate the vector, right? So we need to allocate the vector for the data, right? So we're reading that into a vector of bytes, right? Std vector uint8, and this is a file data, right? Then we read file. I have no idea what it does, but it apparently, judging by the name, I think it reads the file. So as in file c str and then file data, right? It returns the result, and result is this thing. Okay, result, and it succeeds, but can we do an opposite, like not succeed? Is there something like failed? Because I want to do an opposite thing. Define, is that define, or is that... Maybe it's actually Boolean. It should return, yeah, okay, it returns the Boolean. And, okay, so there is a failed. And it's actually as easy as just like comparing it to okay or error. Why do we need that? Anyway, okay, so if failed, I want to just like print something, you know what I mean? Error could not read file, and we can provide the file that we couldn't read. And let's put it this way, and then I can return with non-zero exit code, right? So then it will return in here and return everything. So yeah. So after that we can print something, for instance, red file data size, if I remember correctly. In STL the size of the vector is size, bytes. Right, and in here we might as well put something like this. So read this amount of bytes. Okay, so let's actually copy paste the tool, the not the tool, but the executable that we're going to be converting. You know what I mean? Right, so I'm going to do probe test wasm 64 to 32 ID. Let's take this thing, right, and like literally copy paste it in here. So main 64, right? So main 64 wasm, okay, and we need to recompile it first, of course, right? So let's recompile it first. Welcome to C++. Okay, what do we have? std. Welcome to C++ again. Should have actually like should have not recompiled it and just followed all the errors, but whatever. Okay, so we read 724 bytes. Is that true? It's 724 bytes. We managed to read 724 bytes. So what's going to be the next thing? Sun3, thank you so much for 500 bits. Thank you. I really appreciate that. Okay. After we read everything, we need to basically create binary options. So we need errors, modules, and stuff like that. Okay, so let me just copy paste this thing, right? So because apparently this is the main important thing, right? You construct an options and then you just provide options in here. Everything else is just like global parameters that controlled by the flags, if I understand correctly. So let me try to compile this thing and see if it's gonna work. Right. S features. S features is what? Let me see. S features. So this is a global thing, right? So this is a global. Ooh, this is very interesting. So add options. I wanna take a look at that. Add options. S features. Add options. Do we have? Oh, we even have just features in here. Add options. It accepts the parser. So it probably sort of like enriches the parser with additional flags that enable or disable features. Oh, X macros. Ooh, this is actually pretty cool. Oh yeah, okay. That's pretty cool. So there is a centralized place where you have all of the features and they are using X macros to generate like additional code to set features to enable, disable, and stuff like that. Do you guys know what is the X macros in C++? X macros. Right, it's sort of like a pattern, right, that allows you to do this kind of stuff. Right, so you have a list of variables that call to macro X, right, but they don't define X, they just call to that X. And this is basically means that whatever is going to be substituted by X dependent on the context, right? It's dependent on the context. So first thing you do, you define that X, you define the context, then you expand this list. This list will use these additional macros, and then you undefine that, right? And that way, depending on the context, you can change to what this macro is expanded, right? And this is a good example. For instance, I have a list of features, right? So here's the list of features. Then I want to generate a class that for each feature creates 4 methods. And that's exactly what they define in the context. So this is actually pretty cool. Like, I haven't seen the X macros in a while, for quite some time. So this is very convenient. So I've seen them a lot of times, but I didn't know they're called X macros. Yeah, they're called X macros. It's a completely arbitrary name, which makes it actually kind of bad, right? Because like there's no reason why it's called X, so it's kind of difficult to remember in my opinion, right? But I don't know if there is a better name for this kind of like pattern, but yeah. So you don't need this kind of stuff in Jai, for instance, because in Jai you can literally just generate the code. You can inject in the compiler event loop and just on specific events, just literally add new code at compile time. Like you don't have any of it. You don't need any of this. All right. So, and in case of Jai, you would probably just have a structure that defines all of the features, and you would generate additional code around that structure, right? So at compile time, you would just find this structure definition and iterate through all of the fields, and for each field, you will just generate additional code, like whatever the code you need, right? So you wouldn't have to do any of this stuff. So yeah, let me see. It's exactly how John is implemented CL. Yeah, I've seen that stream. Alright, so what I was talking about, so features is just like, but do I really want to enable features through flags? I don't really want to do that, because there's specific features that I want to always enable, right? So features. I want to always enable, so how do we do that? Features. I want to always enable memory 64. I wonder if I can do that. Feature def memory 64. Okay, so there we go. So wasm 64 enable memory 64. Right. So I always want to just like do that. I don't really care about everything else. So slog string. So there's too much bureaucracy. Why there's so much bureaucracy in here? I hate it. MK Vitas, thank you so much for tier 1. So yeah. Let me go back. Wasn't to what, and where is that stuff? Okay, so on top of that I also need errors and module, and this is where we're gonna be reading all of that. Stop on first error, sure, I can enable that as well. What else do we need in here? So we'll have to go through the compilation errors and stuff. Okay, so slog. So it's that thing, and okay, we can enable that, why not? I don't see anything wrong with that. I suppose eventually I'm gonna copy paste the whole thing. Right. So, and this is the verbose, right? This is the verbose. And for the verbose, we also have verbose in here. And do we need anything else? Okay, so read debug names. So is it always true? Okay, read debugs names. know what? I think I'm gonna just like put these things as global stuff, but I'm not gonna bother hooking them up to anything. Right, do they hook up? Yes, red. Yeah, they're hooked up. I'm not gonna hook them up into the flags because I couldn't be bothered. Couldn't be bothered. Okay. So generate names. So this one is not used then. Okay, I suppose we did it right. If a result failed, failed result, std cout, error could not parse binary data from file as in file, new line, and exit, actually not exit, but return 1. And after that, we may want to try to print whatever we read. Right, so let's actually go to here, struct module, right, where is the module? And let's get all of these things. Yeah. Okay. So let me see. So module. Size. std out. std end on. Okay. wasm 64, and we're gonna provide main 64 wasm. Does it look like a truth? We have 3 functions. Is that true? Why do we have 3 of them? Because I remember I defined one, iterate, maybe another one is an import. We can always do the following thing. We can do wasm to what, and we have to enable the memory 64. And what kind of functions do we have? So wasm call constructors. I have no idea what that is, but maybe that's the third one. So here's the constructors, here iterate messages, and I suppose another one is the import. Okay, so that's why we have 3 of them. So yeah, we managed to parse the binary data. How about that? Isn't that cool? So we parse the binary data. Yeah. We just parse the WebAssembly binary data. We called to the other code, right? So the code we didn't write, but okay. Pogue indeed, that's what I'm looking for. People don't pogging, like nothing happened. Sometimes I'm starting to feel like I'm gonna invent like a cure for cancer on the stream and nobody's gonna notice anything. You're missing the content, chat. What the fuck? You're missing the sweet, juicy content. Alright, so what we need to do in here, we need to iterate through all of the functions. First of all, we need to set the memory to 32. No, we need to validate assembly. I think read binary doesn't really validate it, right? So if I go to wasm2, do we have a validate assembly? No, we do have it. It's even called validating here as well. Okay, so all right, validate assembly. Validate is just like, we provide the features as well in here. Okay, I'm pretty sure I can just like do it like that. I have no idea what is generate names. Do we really need to generate names? I don't think we need to generate names. Fuck that. All right, so let me put it in here. So this is validate, this is the features, and we're validating this stuff. And if failed result, right, a failed result. Okay, validation failed. Okay, and we can put nothing in here. I don't know, can I get the exact precise error message in here? Right. You know what I'm gonna do? I'm gonna just build first and then run this entire thing. So features conflicting declaration. Okay. Can I just call this? Oh man, this sucks. I probably can do something like this. And then we can do something like this. There we go. More than 64. Okay, so everything is okay. It seems to be. It seems to be that everything is okay. Cool. Now, you know what? Like, I don't really have to do it like that. Can I just like inline this shit so I don't have to have this ugly block? I'm pretty sure I can have it like that. Yeah, there we go. Because it's like C++ developers, I swear to God. Anyway, so what I want to do, I want to find the memory, right? So the problem here is that you can have several memories. You have to have several memories, but the good news are that multi-memories is an extension, and not multi-memory. It's an extension, right? It's an extension that is set to false though. Right. Okay, we're gonna do the following thing. I'm gonna explicitly disable multi-memory, right? So I don't really want to support multiple memories right now. It's an extension, so nobody cares. So we're not going to have multiple memory. I suppose this class means like you can pass this class to places where appropriate, and if something is trying to use the feature that is disabled, it's going to throw an error, right? For example, I suppose the validation is not going to allow multiple memories if the features are disabled or something like that. So this is actually a pretty cool way of doing that. I really like that. Pretty cool code. Not gonna lie. Okay, so validate module. So I suppose you may not have a memory declaration at all. So we're gonna do the following thing. If module, is it called memories? It's called memories. Size is greater than 0. We're going to do module memories 0. And I'm going to go into struct memories. Memory. I'll have to take the page limits, right? Taking the page limits. And then, if I remember, it's located in common. Okay. Is 64 false? There we go. You know what? Why do we even care? Why can't I just do the following thing? For outer memory module memories memory page limits is 64 false. And it doesn't really matter if it like supports multiple memories, it doesn't support, it's just gonna work anyway. Like, why can't we just do that? So, okay, and now that should break the executable. So if we try to validate this thing second time, right, it should fail. Because we're gonna have a lot of loads and stores that operate with 64-bit integers, but memories are indexed only with 32 because we said so. Right, so let's actually check if it's gonna, you know, throw an error or whatnot. All right, let me see. Okay, so it doesn't even compile. So I suppose this is because of that, right? So it's a pointer. Auto-dereferencing in 2022. Where is auto-dereferencing? Second validation failed. I wonder if I can make this thing to print this stuff to standard error, if you know what I mean. So validation. How do you print the errors though? So let me see. So they don't print anything. Ooh. Is that how we do that? I think this is how we do that. So we pass, yeah, this is actually quite cool. So we have errors, we pass them everywhere. So they're basically accumulated. And then once we're done, right, once we're done, we sort of like printing them to file. But which file? That's a good question. So let me see. Oh, by default it's a standard error. Okay, so that makes sense. Sure, I'm fine with that. Okay, we can put this stuff like everywhere. Like every time there is an error, we just do. Maybe I don't even have to. Well, it would be nice to know like what stage it failed on. Right. So I think that's useful. I think it is in fact useful. Okay, so let's try to recompile that. Okay. Okay, look at that. Look at that. So this is precisely what I was talking about. Right, loads and stores and shit. Loads and stores and shit. But on top of that, we can try to find all of the loads. Right, we can try to find all of the loads and everything. Okay, so but to do that we need to iterate through all of the functions. Okay, so outer func. So let's actually not do the second validation for now, right? So it's gonna be 0, and we're gonna just exit with this thing. Func module struct module. Where is the function? So it's a funcs, right? So this is funcs, and what do we have in funcs? Func. So what's interesting we have? We have a name, for instance. We have declaration, local types, bindings, expressions, expression list. Okay, so I think expression list is the thing that we care about, but for now I want to focus on names. Can we extract the names of all functions, right? Something like std out, func name, and just std handle, right? Let's see. Okay, here they are. Here are the functions. So print message, wasm call, constructors, iterate messages, and so on and so forth. Right, so we got the messages, cool. The next thing we need to do, we need to probably iterate through their bodies. I presume the bodies are located in expressions, and which is an expression list. Okay, so let's find what is an okay. Intrusive list. Intrusive list. Is that a C++ thing? Embedded template library. Is that like a homemade? Holy shit, it is a homemade thing. They implemented a STL container. Okay. This uses a similar interface as stdlist, but is missing the following features. Add extract functions that remove an element from a list, return. Only supports move-only operations, no allocators support, no initializers, very intrusive list. Asserts instead of exceptions some why? Why? I'm not gonna question that, but yeah, anyway. So, okay, expression list is an intrusive list of expressions. And what is an expression? Expression is a class, alright, which inherits intrusive list base. So where this thing is located, what is intrusive list base? It's located in here, and it's a friend with intrusive list, which means intrusive list can modify its private things, and it has next and previous. Oh, it's literally a linked list. An intrusive list base is a node for this thing, and expression is a node for linked list. It is not copyable or anything. Okay, so that's fine. We have different types of expressions, and that is about it, which means that this class is supposed to be a base for other. Okay, so there is a all right, there is a hierarchy of different expressions. We're okay, we're going that route then. Okay, I haven't seen that stuff for quite some time already. Oh my god, I'm having a PTSD right now. Holy shit. I thought I'm never gonna see this style of software development ever again in my entire life, but here it is again. Oof, okay. I mean, it's not that bad. Okay, yeah. It's just like it's a hierarchy. It's a hierarchy. Nothing particularly special. Everything's fine. Okay. What kind of expressions do we have there? I'm actually curious. Expression mixin. Memory binary. Ooh, this is actually pretty cool. Ref type. Opcode. CMD. Look at that. Select expression. So that's pretty cool. If expression. Look at that. So it has two branches, right? True and false. And this one is a block, another one is expressionist. What's the difference between block and expressionist? Struct block. And it also has expressionist. Okay. So this is basically a tree with linked list, where each node could be either an element or linked list, essentially. So, okay, which makes sense, right? So, because we need to represent this thing. So let me just do this stuff. I probably have to go to build. Right. So we need to represent this kind of thing, right? So this kind of thing. How can you represent that? You basically have a linked list, which is a node in a tree, right? So each thing is a separate node, and then we have a block, right, which itself spawns another linked list, and yeah, so that's how you represent this entire thing. The question is, like, on which instructions we can branch? On which instructions we can branch? So that's a good question. Right. So let's create a function patch func, and here we're gonna accept the function that we need to patch, right? So might as well even do something like unimplemented, right? Patch func. And I'm gonna do patch func. If I remember correctly, it's just a pointer, so here I could have just done it like that. So where is the class module? Is it class or is it a struct? I don't remember. All of them are pointers, so that means it's safe to just iterate it like that. So my only concern is that, like, we can just iterate through the expressions, right? I can always just do something like this for outer expression func expers, right? So, and what kind of expressions are we looking for? Right, class exper. Right, so we have to do expression type. Okay, so exper type. And expert type is what? Okay, so here are like different types. Atomic load. Do I have to handle atomic load? I don't know. We'll see. So there is just load. Load splat, load 0. So I'm not sure. So there's also store. I'm not sure if these things are important for us. I think I'm gonna only care about store and load for now. Right, so here I can do switch. So case expression type store unimplemented patch store, and in here we're gonna have a separate thing which is a patch load. In default we're gonna just basically ignore this entire thing. Right, so this is very cool, but what if I have if, right? So there is if something like maybe block, right? So block. Okay, so there is a block expression base or something like that. Expression type block. So how do we do that? Expression type block. Okay, if there is a case of expression type block, right? So I'm just looking for like the ways how people handle that, right? So here's expression. They take a look at the type, and if there is a block, okay, so they do something with that. Oh, there is a special function that can cast the expressions. Where is it? Okay, so there is a cast.h. Oh, okay, so this is gonna be, so there's a function, special function that allows you to cast these expression hierarchies and stuff like that. So, oh my god. I'm starting to think maybe I should have actually written like a shell script that, you know, just patches the text representation. But I mean, it adds a lot of moving parts, right? So, and it's not particular for this platform. Ooh. So much useless code. Anyway, which is fine. Okay, so this is a block expression. So what is a block expression? Let me find that in IR. Block expression. So there's a block. Oh, okay. So block expression is a alias for block expression base, which is parameterized by a template. Okay, so there are two. Okay. So it's just like for the code reusage, right? And essentially, what I have to do, right? Essentially, what I have to do, I think, is when I encounter something like case expression type block, for instance, right? I have to do something recursive. To do something recursive. You know what I mean? You know what I mean? Just do something recursive. So that means we need to have something like patch expr list, right? So expr list. Is that a pointer, by the way? Expr list. No, it is not. So I have to do it like that. Exprs, right? And I probably want to move this entire stuff in here. Right, so this is just that, and then I do patch expr list, right? Expr list, func exprs, and I can say that this thing is implemented anyway. So that means when I encounter a block, what I have to do, I have to cast this thing to block expr, right, and then take block expr base block struct block. Okay, block exprs patch exprs. Oh. Okay, cool. Something like that. But the question is, like, how many of those things I have? Right, I have to do that on block. I have to do that on loop. Like, how many of those do I have? That's the real question. So I suppose we can see how it is usually iterated, right? So if I take a look at wasm to what, right? So at the end of all of the transformation, what do is we write what. So there is a function that takes a module and writes the module into the file. So let's actually find the function write what. Write what, where is it located? Okay, it's located somewhere in here, and let's see how it is done. So there's a what writer. Of course, there is a special class that does that for you. So it's a module context. Okay, so what do we call in here? Write module. Write module. So what are we doing here? So we iterate through the module field. Okay, so write func. I think write func is something interesting. So what are we doing here? Write bindings param, begin func. So where do we do write folded expression list? Get expression type, get expression arity, push expression. The fuck? Flash? The fuck are you doing? Expression tree stack. Ooh. Okay, I see what they're trying to do. Yeah, so because you have to pre-print that. You know what, I'm not sure if it's a good idea. I want to take a look at the wasm, what to wasm, right? So because this is a very complicated, so we have to traverse that in a very specific way to achieve a specific result because it's a text representation. So it's not going to be straightforward recursive traversal. So I don't think it's a good idea to look in here. So what we need to do instead is what to wasm, right? So, and how do we do that? Write buffer, write binary module, I think. So here we accept the module, and that's basically it. So let me try to find that. Emacs, shut the fuck up, Emacs. Okay, so what do we have in here? Okay, so binary, of course there's a binary writer. So, and we have a write module, right? So how do we do write module? So I'm looking for a function. So when we do function, expers. Oh man. Okay, write expr list. So this is probably what I care about, because that is kind of resembles what I'm trying to do. Okay, so this is actually literally what I'm doing. This is literally what I'm doing. Okay, so there's a block. Yes, that's probably what I need. There is an if loop. Okay, so I feel like I have to go through the syntax. Oh, there is also try. Oh boy. Yeah, we'll have to do something about that. Okay, so I'm already streaming for 2 hours. God damn. So let's make a small break. I need to make a cup of tea. And after I make a cup of tea, we're gonna continue doing this thing. So I just need to, go through all of the expression types and just find the ones that look like a block and iterate, just do a recursive call on them. That's it. I don't really need to do anything else, to be fair. Right, so yeah, I think the easiest way would be to just like do that manually, I suppose, right? So type expr, expr type, yeah, there we go. So just like go through all of the almost 69 things, and look for the one that looks like a block, right? So something like if loop try, for instance. I'm pretty sure it's a block. Throw. Yeah. All right, as long as I'm break. All right, so let's continue. What I need to do. So handling loads is probably the easiest thing to do, right? So if we encounter load, we just have to put the conversion instruction right in front of this thing. So the question is, does intrusive list allow to insert things? It does. Very cool. Right. So I presume there's no really documentation on how this thing works. Insert. Right. Where does it insert things exactly? I don't want to understand this thing. So I suppose if the interface is similar to stdlist, right? So that means the stdlist documentation should be useful for this specific container. Just a second. All right. So hopefully you can hear me relatively well. Okay, so insert. Okay. Where does it insert? Insert the element a specified location, insert the value before position. This is actually perfect. Is it? I think it is. Oh, it also accepts the nodes as a unique pointer. That is rather interesting. Can I just look for inserts? How do you use them? Well, oh, okay, so this is a test for intrusive list. So they have a make unique thing, make unique function, which has a dedicated file called makeunique.h. Okay, this is named makeunique instead of makeunique because makeunique has the potential of conflicting with std makeunique. They spent so much time documenting this, locating the whole file. It's like the law of triviality, right? So it's a disproportional attention to a very trivial thing. Okay. Cool. So I'm sorry. it's pretty funny. There is like a huge problem in software development where people really allocate like really disproportional attention to very trivial things, right? And like actual substantial things usually don't have enough attention. Right, like why did you spend writing, like really? I don't know. So anyway, sorry. So we're inserting by an iterator. So that means we have to iterate this entire thing by an iterator. So we have to do something like iter expers begin, if I remember correctly, right? So this is my C++ 03 reflexes. Right, I can't even call it it. Yeah, boy. It not equal expers and... Oh man, I feel like I'm in high school yet again. This is the shit I've been writing in high school. What the fuck? This brings back so many memories. Like nobody writes C++ like that anymore. You guys remember? Do we have any boomers who remember how to write such code and what this means? All right. Anyway, so in here we'll probably have to do something like this. Let's actually try to compile this into STF. Be boomer, exactly. So let's see. welcome to C++. So expers, so since this is a pointer, we have to do it like that. The next error, thank you very much, the next error is a request for a member end, which of the pointer, what? Could not convert store to type error. Oh, okay, so there was an error here somewhere? Or what do you mean? Unimplemented was not store from expression type to type error. So some error has happened there, and this is so weird. And it doesn't really tell me exactly what the fuck is going on, but okay, sure. Is that because I have to do... I feel like I have to do something like this. Yeah. Man, I feel really bad. So the expression list, let me actually go through this entire thing. Expression list is a bunch of expressions, right? And in expression class, we have a type, an expression type. Does it have a store? It does have a store. So it should just work. It should just work. So, but the... Well, I didn't see any problems. I don't understand. Is that because of the unimplemented? Because I just don't have it anywhere? I can define it. Right, so it's gonna be a message. You could have just explained to me a little bit like more, you know, properly. What do you mean? That would be actually kind of cool. So can we do something like file, then this, then line, unimplemented, might as well do something like this, and then message, something like this, then exit 1, so that's the only thing I want to do right now. Alright, and let me try to compile this into a thing. Okay, so that was the reason. Okay, cast. Do we have a cast? Thank you so much for such a beautiful error message. Really appreciated that. Okay, so expression, so there is just this. Oh, and this is interesting. So I have to take the pointer yet again to actually properly... Okay, I see what's going on here. I see. What else do we have in here? So expression cannot convert expression to expressionist, so I have to take the pointer of that thing. Okay, I see. Oh boy. So and in here we also have to take that by a pointer. Okay, so it compiled. Cool. Patch, so okay, it even tell me that we have not implemented this thing. That's pretty cool. So for now, I think I'm gonna just like not do anything. Right, I'm gonna comment that. So the only thing I care about is load, probably. Right, load. So what we're gonna be doing with load, right? So I have expressions. And since this is a linked list, right, inserting into this thing should not invalidate any of the iterators, so that should be fine. Right, and what we have to do in here, we have to do make unique, right, and what kind of expression do we put in there? That's a very good question. So, do we have something like wrap? So the operation, oh, I see something. Ooh, so opcode. Okay, that's cool. So this is the instruction that I have to insert in here, but how can I construct such instruction? So oh, convert. So there is a convert expression then. Okay. Opcode expression, and there is a opcode. Okay, so that's cool. Class opcode expression. You can, okay, you can construct an opcode, and we know opcode, it's a i32 wrap i64. Yes. So convert. So that means I should be able to do something like convert expression opcode i32 wrap i64. And is that what I can do in here? I feel like that's what I can do in here. And that should be it, actually, believe it or not. Okay, it did something. I'm not sure what exactly it did, but anyway. So we patched the memory, we patched the functions, but then we need to validate it afterwards, right? So the second validation is important. The second validation is extremely important. Okay. Oh, it patched all the loads. Would you look at that? That's actually really cool. Wait a second. So if I comment it out, right? If I comment it out, here is a bunch of loads. There was like 4 loads, right? And then we patched them out. So the only thing we need to do now, right, is to patch stores and also patch the data, right? But that's a completely separate story. All right, so stores is rather interesting because for the stores we'll need to implement some stuff. We'll need to implement functions that do the conversion. So here is we do memory patch function, and let's do the following stuff. First of all, we need to create a type, right? So we need to create a type. Let me see. So this is the IR H. So class module. Is that a struct module? Right. Can I just like append? I can append fields, certain fields, and I can have a type module field. What is that? And you can have a type entry. And what is a type entry? Type entry. Oh, it's another hierarchy. Holy shit. Okay. Function type, and you can have a function signature. Function signature and class class func signature. It's actually a little bit cold in here. Just a second. And okay, so there's the param types, result types, and so on and so forth. Okay. Almost 3 hours. Holy shit. Okay. Type. Need to go again to module. Type module field. And type module field. I suppose we can just construct type module field, right? Func type, make unique type module field, right? So let me try to recompile this entire thing. Okay, so it seems to be working. And then within this stuff, IR, this is like unnecessarily complicated, I'm not gonna lie. Type entry, and type entry is more of an abstract thing, and more of a specific thing is a func type, right? So this is more of a like type field, right? So this is a type field, but I don't know if I can just specify the type. So I have to construct them separately. Okay, so I feel like I do have to construct it separately. Okay, so then I have a func type, which is a make unique func type. Let's see. I swear to God, like, why people write code like this? Func type. So, and in here we have to access the signature. Func type signature. Right, and what do we have in that specific signature? We have param types and result types. Param types and result types. That's what we have in there. Right. So then for the param types, this is a type vector, right? So this is a type vector. And what is a type vector? I'm pretty sure it's an alias for some sort of a vector. Using, yeah, I was right. It is this, that. So it means I can just push back, and I have to push something like type. And how can I construct a type? I can just provide the type and enumeration. So it's essentially type, type. What kind of enumerations do we have in there? Okay, so we accept I64. So this is the parameter. This is the first parameter, and then we accept I32. So we're going to generate the thing for value 32, right? And then we're going to return 32 two times. So we constructed a signature for the function type, and then we have to set type. I already forgot. Type module field. So this is the type to func type. I wonder if I can actually do something like this, right? And then type field type. Can I do stuff like that? I wonder. Okay, let's see. Are you sure about that? Oh shit, okay. So because we lost the type, yeah, I see. We have to do it like that because it is more abstract, it's just the type. So we're losing the specifics. That's why we have to do it like that. Okay, so what do we have in here? Cannot bind our value. Ooh, do I have to move it inside? Do I have to move it inside? Yeah, okay. Okay, so essentially, when I try to assign, I actually make a copy. But I think the copy constructor for the func type is deleted or something. So type entry. Yeah, disallow copy and assign. So copy and assign is disallowed. So C++ is such a good compiler that it cannot just tell you that copying and assignment is not allowed. It literally have no ability to say that to you. Instead, it can say some gibberish about L value and R value. Right, so, but what it means is that you have to move that value. Welcome to C++, by the way. Cheers. So, yeah. Anyway. After that we can do module, and I think module had like a thing to do that. Oh, you can literally append the field. Right. So it's a type module field. Yeah, append field type field. Alright, can you do that? I should be able to do that. Okay, so we didn't like that. Okay, probably the same situation. We want to move that inside. Okay, so that seems to be working. So this is just a type, right? But for that type, we also need to generate a function that uses that type, right? That's what we need to do. So let's define a func field, right? So there is a type field, there must be a func field, right? So func module field, and it has a function, which is not a pointer, by the way, which is good. So make unique func module field, right? And in func field, we're accessing the func. What do we have in func? Okay. We have a name. Do we care about the name? I don't think we care about the name, so whatever. Function declaration. I think we do care about function declaration. We care about expressions, right? So expressions and function declaration. I don't think I care about anything else. Function declaration. So has a function type. Well, it's probably true, right? Function signature. Oh, so you can have like a type in place. I'm not sure what that means, but can I just like do a very dumb thing? Not really dumb thing, but signature, right? And just like use that signature so I don't have to define the type for this stuff. Can I do it like that? That would be actually kind of poggers, wouldn't be? Okay, so we have that. So it has a func type, and func type. So it probably, you have to set it to true, and then you can refer to type var that you define in here, but I'm not sure what is var. Struct var. Var. I don't know what it is, but maybe I don't even need any of this stuff. Maybe I can just do it like that. But... You know, the only way I can check that is by like literally appending that thing there. Alright, so module append field std move func field. Alright. Let's see if it's gonna do anything. Mismatch type store. Type mismatch and implicit return. It means that it tried to validate the function and function didn't return anything. It's the same error as we had when we manually modified the WAT file. It's complaining about that function. Holy shit. All right, so that means we can start doing expressions. And for the expressions, we can probably just push back a bunch of stuff. Right. So can we have like a local, we can have a local get expression, right? And this is a var expression, and the var expression, okay. So that means we can do something like make unique local get expression, and we have to provide the var, and I have no idea what the fuck is var. It's an index. What the fuck is index? Is that a struct? Where the fuck is index? I'm sorry for swearing a lot today. I'm programming in C++. Oh, okay, it's just a number. Oh, it's an operand. Like you can get 0 and get 1. Okay, I see. So that means I should be able to literally do something like this. So that should now get the parameter of the function, so it will complain that it has one number, there we go, it has one number but doesn't have the second one. So the next thing we need to do, we need to convert that stuff to 32 bits, and we already know how to do that. We already done that before. Right, so that's the instruction we want to insert in here. Right, so that's the instruction we want to insert in here. Come on, you can do that. Yes, I32, so it actually converted that. Okay, so I can program in WebAssembly from C++. So what I need to do now, I need to take the second one. Okay, that's cool. Okay, so it validated the function that I generated from scratch, and I actually didn't need any of this stuff. I didn't need any type, so this is actually very convenient. So let me see. Let's do the following thing. Generate store wrap for type, right? So, and I'm gonna move literally everything there. So, and essentially we're gonna accept the type, right? We're gonna accept the type. Here we might as well accept the module and the type. So we're generating this thing for this specific type, and we're converting 64-bit pointer to 32-bit one. So, yeah. I don't really know how to refer to these functions yet, but we'll see. So, and essentially, I should be able to just generate store wrap for type. So here's the module, and the type is type I32. Then I can generate it for 64, and so on and so forth. So for this kind of things, we can generate different things. All right, so that's cool. So we already generated 2 functions. Okay, so there's some problems in here, but it's not that big of a stuff. Code generation, yes, exactly. We're doing code generation. Local variable is out of range. Function, but what are you talking about? It was fine. It was fine before. So what's wrong? I don't get it. Function type variable. Function type. Wait. What changed? Excuse me. Was it important? So let's actually go back. Was this thing important? This is sus. Okay. If I remove this thing. This is truly sus. I think it still needs the type. Okay. So I can do that. But oh, I suppose it just looks up that type. Yeah, okay, I see. You can't use this type if it was never declared or something? Maybe that's the problem in here. That's a really weird way of doing that, but fine. So generate wrap store for type module type. Okay. Sure. So we're gonna accept that. And let's put this thing like that. So this is the type, this is the type, this is the type, this is the type. Okay, for a second I thought it's gonna rebuild literally everything. Okay. So, and now generate wrapped store for type module type i32 i64. So I was right actually. Okay, so let's find all of the stores now and perform the corresponding calls. But that's a problem. So let me see how can we perform the calls. All right. So expression type call. That means there is a call expression. Call expression is a variable expression, and a variable expression accepts some sort of an index, and I presume the index is basically the index of the function. Okay, so that makes sense probably. If I remember the WebAssembly format correctly, right? I kind of roughly remember. I remember that when you want to call a function, you refer to the function by the index in the array of functions, right? By the WebAssembly format. So that's what I remember. So I suppose we can get the index by, like, yeah, by looking at the size of the functions. Right, if you take a look at this thing, struct module, right. So here are the functions. You can take the length of that thing. So funcs size, and we can just store it as an index. Func index. Right, we can try to return this thing. Func index. All right. So, okay. And we can return that index in here. So index store i32, and then here we can have store i64. So for now, what I think I'm gonna do, all right, I'm going to accept store i32. Right. I'm gonna just, like, you know, pass them there. Let's see how it goes. Okay. Cool. So what's it complaining about? This is weird. What the fuck? Wait a second. Type mismatch. Really? Am I going crazy? Did I fuck up the generate wrap type? You know what, maybe instead of declaration I have to do something else. So func declaration. So maybe I should leave the signature alone. Alright. That's what it feels like. And just do has function type. I'm gonna set it to true. And then I'm gonna set the type variable. Type var. I'm gonna set it to the type. So outer func type index. And this is essentially module types size. Like so. Func type index. So let's give it a try. I'll probably have to wrap it in a var. Expected I64 but got. What it says, essentially, it says that so what's up with this shit? So let me see. Type assign. Oh, they are just taking an array. And then just append. Okay. So binary reader. Oh, set function declaration. So signature index set func where is it? Why is it in a different file? Is it in a different file? Okay. Well, that's literally what it does. It just sets that thing and that is it. So I didn't think it's that big of a problem. Okay. So making so type module field. I'm only curious why it didn't work. Maybe this is not what I think it is. Maybe this is not what I think it is. Right, so So let me only start with one. Oh wait. So this is not what I think. Okay, that makes sense, I think. All right. Now we can just put something in there, just like 0. Okay, so it caused not by the generated code. Okay, so I spent so much time trying to understand like what. Oh, this is because. Oh my god, I'm so tired already. Okay, I just copy pasted the code because I wanted like a placeholder, right? So for which I'm gonna change to call expression. I forgot about that, and okay, I see. I'm just already tired. Like the stream took too much time, right? So that's literally the reason why it's like that. Okay. So now let me see. But basically I discovered that you don't need to define types like that, or maybe, I don't know. We'll see. So, and here what I wanted to do, I wanted to do a call, right? So this is my RH, call expression, right? So this is a call expression, this has to be a var, right? And I can just do store I32, right? Store I32. All right, so what do we have in here? Unused, but where is the actual error? Could you please give me the actual error? Oh boy. Okay, so required from here. Oh, you have to do var. So maybe I should always wrap them in var. Type mismatch in initializer expression. Yes, I think we solved all of the problems. I think initialize expression is the data. Right, so just a second. Yeah, just a second. Wasm to what? Main 64. We have to enable memory 64. Memory 64. It's this. Yeah. It's this thing. Remember, we did the data, and we also have to do this kind of stuff. Oh boy. Okay. I guess that's the only thing we need to do. But I don't know how to do that. Module. Data. I think it's a data segment. Yeah, it's probably the data segment. So struct data segment. And what do we have in here? Ooh, wait. Really? So this shit could be an well, it is an expression because I64 const is like an operand. It's an instruction. So you can have shit in here. Oh, so but can you have like an arbitrary shit in here? So that's a good question. So what kind of stuff can you have there? So apparently this is a const expression, right? Can you have any shit in there? That's a good question. All right. Can you really have any shit in there? Maybe not. You know what? I'm actually gonna hardcode that. Because I don't think you can have anything in there. Right. Patch. Expert. What we're not gonna patch expert list. What I need to do is. What is it called? Initializer expression. Okay. Patch init experts. But to do that, we need to go through all of the data segments. Data IR struct module data segments. Okay, data segments, and then data express. So here we'll have to accept patch expr list. Come on. Yeah, so that's what we need to do. So, and in here, I suppose we can just do auto expr exprs, and we can switch upon this stuff. Case expression type, what is that? Const, right, I'm pretty sure it's const. Expression type const. Yeah, there we go. Expression type const, and if it is expression type const, we have to modify that. So it's a const expression. So it has an internal const, and it has an internal type. Set u32. What is from? This is so weird. From accepts the type and data, does some assertions, sets the type, and sets the data. So to change the const to u32, I literally have to do something like set. That is such a weird code. Why? Okay, I mean, sure. I mean, I don't care if that's your thing. So we have to do cast. What was that? Const expression, right? Const expression. So pointer to the expression. We cast that. Then we take the const, right? Then we set u32. But to do that, we have to get this entire thing. Oh boy. All right. So essentially, I can do something like auto const expr, right? Const expr const. I can take this thing, and then I can set this thing. If we encounter anything else, this is a straight up unreachable. Right. So essentially it should break on anything that is not const. Right, so literally hard coding. It should be fine, I suppose. So do we call that anywhere? Do we call that anywhere? Okay, we don't have... Though we take a bit pointer, right. You know what? Let's do the boomer style shit. Auto begin and equal exprs and the plus plus. So this is it. Sure. Goddamn C++, useless language. Okay. Okay, unreachable, unimplemented, unreachable. Okay. Data segment doesn't have a... Are you serious? It's called offset. Sure. It just validated the second part. We successfully patched that shit. We actually did. We successfully patched that. Alright, so, but we need to save that binary thing. So we need to open what to wasm. So how do we do that? Memory stream. Write binary. So we have to create some sort of a stream. And it's a log stream, slog stream. Right, and it's set. Well, this sucks. S log. Wait, what? Create stdr s log stream. So the only thing we need to do, we need to save that somewhere. Ah, it's needed for the logging in case something bad happens or whatnot. Okay, whatever. So I'm just gonna go and just do that. So we validated the second thing. Then if it failed, right? Oh, default output name. This is actually cool. I think I can use that. Failed result. Error could not generate binary data for the patched module, right? Something like this. And then we're gonna do format write to file errors, location type binary, and then return 1. So then let me see if it's gonna compile. It's probably not gonna compile, but so it needs some shit. S write binary options. Okay. Not sure if I care about these things. So can I just like construct that stuff and never set anything? So S write binary option relocatable. Write all 5 bytes, debug names. No, I really don't care about any of that stuff. Oh, and it's okay. Binary, yeah. What else? Features. Get. I think it's from unique pointer. I don't think we need get. Next one. Module pointer. Yes. Okay, it successfully generated something. If I understand correctly, then we're saving it to a file. Right, then we're saving that to a file. So we have to do something like that. Then we're writing that to stream output buffer. Okay, so that should be fine. But I don't think it's gonna work. Default output name. I feel like default output name depends on what kind of thing you're doing, so it must be the function that is... Yeah, okay. wasm extension. So let's put this thing somewhere here. String view, by the way. Strip extension, and what kind of extension do we add? So what we're gonna put in here, I'm gonna put 64 to 32 wasm. Right. Get base name. Where is it? Get base name. File names. You're freaking serious. Wait. Did I modify? Okay, I'm an idiot. Should have actually put it in here. Okay. Write buffer file. Where is it located? Oh wait, it's a... Are you serious? You can just do it like that. Why do you need this function? Dump module, dump, it's like additional shit nobody cares about. Okay, so this is what we can do. The buffer is... Really? Stream output buffer. Oh yeah. So write the file name, and the file name is sout file. Okay. Please work already. Yes. 64.2. Yes, we've got it. We've got the shit. Let me take a look at the what. Wasm to what? Main 64 to 32. And what do we have in here? So memory is, well, it doesn't have any type. That means it's actually 32. The data 32. Do we have additional functions? So this is the function parameters. Okay. We have an empty function. Well, empty function, I suppose it's the like init or something. So environment print message. Do we import anything? So, but export. It feels like some of the exported functions were like lost. Oh no. Okay, so they're actually okay. So here are, by the way, the function that we generated. So the wrappers, right? So, and we can generate like for any type in here. So that's pretty cool. I want to take this module now and I want to put it into the test wasm. All right, I'm gonna copy paste it in here, and in load.js. This one is 64 to 32. 64 to 32. And do we have this stuff? Okay, so apparently I have... I see. Okay, it seems to be working. Does it? Yeah, so there we go. We're loading that module and it is works. So we managed to write a tool that converts a 64-bit wasm to 32-bit. So let's actually try to apply it to Jai and see in which places it's going to break. Okay, third party what.bin wasm64 to 32, and I'm gonna just try to do that. Okay, so it fails in some of these places. Okay. Type mismatch. Okay, so could you please stop? It didn't stop. Okay. Oh yeah, okay, I know what it is. I know what it is. Because we don't use store 64. We don't use store 64. So we need to pass it in there. We're gonna have many of them, so we'll have to pass them like always. You know, I have an idea. What if we create a structure store, right? And in here we're gonna have different things like i32, i64, and then if we add more, we're gonna be adding more there. So store. Okay, and in here, I think it makes sense to actually return a variable, var. Auto var. Okay. So when we patch function, we have to do store. Okay. wasm64. Okay, so store has to be defined. Let's define it somewhere up here. Oh, so we'll have to pass those things in here. Okay, patch func. Alright, cool. So essentially here, when I do the store, I need to know what kind of store do I have. Do I have that information in the store expression? What is this load store expression? I need a store expression. Oh, okay, so it's a memory load expression. Load store expression. And we only have opcode, which is, I guess, enough. Right, so do we have opcode? Yeah, we do have that. We have different opcodes. So i32 store, yeah, for i32 store, yeah, that's pretty cool. So we can do it like that. So we can do switch, but that will also require converting to this thing. Auto store expression, right? Cast store expression, it, take that, switch store expression opcode, and here we have different opcodes. Oh, this is actually pretty cool because now if I have something unsupported, I can print what exactly I don't support. Opcode i32 store. Alright, so and that's what I do. And then for the default, I can always say something like std out. Can I actually say that? For the opcode, can I... So the opcodes define also a name, but can I have an access to that name? Opcode. Oh, okay, so there's an opcode. This is complicated. Okay, I can have a name, which is nice. So this is opcode, but this is a type also. Type. Get code. It's an enumeration as well. And does it have a conversion to enumeration? Yeah, it does have it. Okay, this is perfect. So that means I can do stuff like that. And then unsupported store instruction, and we can do something like store expression opcode get name. Right, and then I can exit with 1. Okay, so that's pretty cool. Now I'm gonna go to jailbreak, and I'm gonna try to do that. Unsupported store instruction I64. So what that means? That means I can now do the following thing. I64. So let's rebuild this thing. And now let's do that one more time. I32 store 8. This one is interesting. What that means? That means that it accepts 32-bit value, but stores only 1 byte out of it. Right. So because in WebAssembly there is no I8, I16, there's only I32 and I64. And therefore, you can only store 1 byte by having 32-bit integer, right? So that means if we encounter I32 store 8, we have to redirect that entire thing to I32 store, right? So that's basically what we'll have to do. So can I just add 8? I think I can. Oh, this is not particularly convenient. You know what I want to do? I want to copy paste that main here. So it's a little bit easier for me to work with it, because I want to be able to work with it in a single place. Main.wasm, I'm going to copy paste it in here, and let's just do make and then wasm 64 to 32 main.wasm, and let's see how it's going to go. So basically I'm going to rebuild it and then modify it. So that's what I want to do. Okay, so the same for 16 as you can see, right? Okay, so that's cool. Next one. So I wonder how many of them do we have? I wonder how many of them do we have? F32, so we're getting to the territory of things that we don't support yet. So this one's going to be F32. Alright, and in here, generate F32, F32. Alright. So, and if we encounter opcode, case opcode F32 store, so we call to F32. F64. Okay, makes sense. I don't think we will need anything else. I think there's only like I32, I64, F32, and F64. Right. So that's the only 4 things that we need to generate in here. I'm so tired. Okay. 64, 64. Uh-huh. I mean, it's done, and it even type checked. I was expecting that not everything is going to be type checked because, like, you need... We didn't handle all of the blocks, right? We only handled, like, loops. Like, I mean, there is a good chance that this worked because we do, like, a double validation. This is... Okay, so... Let me see. Jailbreak, I'm gonna just copy paste this thing back. Alright, I'm gonna go to load.js. 64 to 32. Right, so this is what we're gonna try to do in here. So async. I'm gonna remove that. Okay, so there's nothing in here, and let me put Python thingy. Okay, so it's complaining about big ints. It's a very good sign. This is a very good sign because it's trying to work with 64-bit integers. So this is a very good sign. What do we have in here? It's at 46. Ooh, this is a good point. So that means it wants null as a big integer. This is a very good sign. Okay. It worked. Wait a second. Did you notice that this thing started to work? It didn't work before. Yeah, it didn't work before. And you know why it didn't work before? Because it was using the structured literals. It works. This shit works. So this idea works. So the program compiled for 64 bits and we tricked it into working in 32 bits. This is so cool. This utility, by the way, 64 to 32, could be very useful for somebody else, right? Imagine that you have like a 64-bit program that is actually hard-coded to be 64-bit, but you want to run it on 32 bits. This could be useful. I mean, until memory 64 extension becomes like a standard, this is a very useful tool. I think I want to actually like turn it into standalone thing that other people can use, right? This thing is obviously not finished, right? So you need to like add more types in here, or maybe like double check some stuff. But overall, this could be a very useful tool. And as far as I know, I think Wabbit is a library, isn't it? Yeah, it is a library. So I can probably like write this tool outside of the Wabbit source code tree. You know what I mean? Furthermore, Jai can interrupt with C code. So I can even integrate this specific code into the build of the game. Right. The process of patching WASM could be part of the build quite easily, because Jai can like call to this code. Right, so we can do something like that, but that requires like additional stuff. So there's a lot of things in here that you can... Wow. Right, it just works now. Right, and probably all of the bugs associated with like incorrect pointer arithmetic is actually fixed. This is so cool. The code base of Wabbit is actually kind of meh. So it says like a... It feels really strange because it's a mix of like old school C programmer, right? So you clearly can feel like an old school C programmer vibe in here when you just have this like functions, like a procedural functions that you call. Then when you dig down into what these functions actually do, you see the classical CS course OOP course. Yeah, classical CS course, and then you can see some crazy C++ developer like implementing their own STL. So this code base like feels like a mix of like these different styles, like old school C stuff, the OOP with all of these hierarchies and stuff like that, and the crazy STL thing created by a Russian developer under mushrooms or something like that. Yeah. Did you guys know that the creator of STL was actually had like food poisoning when he came up with STL or something like that? Do you guys know that? Alexander Stepanov, right? So, and he was in the hospital when he came up with the STL idea. So he had some sort of like a food poisoning. I don't remember, but it's just like the history behind that. So, yeah. Alright. Anyway, that's pretty cool. So, I finally fixed that bug. So, the structure literals actually work, and I can sleep in peace. So, and I think the outcome of today's stream is actually very useful. So all of that artifacts can be turned into something useful for the community. All right, does anyone have any questions? Does anyone have any questions? I guess not. All right, that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you on the next stream. Love you.